Alright, here we're going to run a code. This code is pretty much to find out how fast the wheel is turning and take that, do the calculation and send it out on a crystal and a LED display. I'm just going to run through the code real quick. This part that you're looking at, that's pretty much to set up our duty cycle or on and off cycle of the power going into the motor. That's pretty much how we're going to calculate our RPMs and how we're going to send everything out to the LCD. And this is our setup right here. We have everything coming out. This is how we're communicating with the computer through our JTAG and our butterfly board. We're sending 3 volt supply to the butterfly board. This 9-volt battery here that's going to our motor, and this is our circuit. One of the main goals of this circuit is to protect any back feed coming from this motor going into our butterfly board and shorting everything out or actually blowing anything up. Here we have an opto interrupter. It has a LED inside there, and what it's doing is reading for any interrupts when that light pretty much comes off. If you notice, our wheel has a slit, so that's going to cause the interrupt. So once it goes through right just like that, right there, that's how it's going to cause an interrupt. And every time this wheel turns and every time there's an interrupt, we're just going to count that, and we're going to count it up and divide that pretty much almost by a second and multiply that by 60 in order to get our revolutions per minute. This is all of our connections coming out here, going through our board. If you notice, you probably can't see in there, but pin 1 on there, that's where we're getting our 3 volts from to run the opto interrupter. And pin 3 on that, we're actually, if you notice right here, this is pin 3 going through the opto interrupter. That's going to pin 4 on our butterfly board, and pin 0 on our butterfly board of port B. That's actually, it's going on, that's connecting to our motor, and that's how our motor is running from that. So let's go ahead and run this, and that way you can actually see it working right now. Nothing is on our LCD, and we're going to run that. Here you go, you can see the wheel spinning. Just give it a little go, and there you go. You can see it's counting the RPMs, which is not that bad. And we can actually control the duty cycle, slow it down. There you go, we stopped it. Sending another duty cycle to it. Notice it's starting back at 1 RPM. And you can see right there, and as it gets faster, you can see our revolutions per minute is picking up. And that's pretty much our circuit. And once we stop, let's you stop everything, everything goes down. So that's pretty much it. And you could actually run it at a different duty cycle, and that way you could see it a little slower. Here we go, you could see your RPMs, and just give it a little go. Right now it's a little slow. This butterfly board is a little slow in reading from actually communicating with the computer. So you can see how that's spinning, and our RPM. Usually what you're seeing is the lower RPMs is what you're actually looking for, not the high one. That's a little glitch in our software. But there you go. You could actually slow it down, and that way you could see it. This actually works better at lower speeds than it does at higher speeds. You stop, and that way you can see it a little. You can notice, if you notice, it's turning a little slower. And you could actually see it right there. That one was about 93 RPMs, 95 RPMs. There you go. So we're between 93 and 97 RPMs on that one. If you notice the wheel is slowing down, then it's speeding up, so that's why it's fluctuating like that. That's why you see the 97, 93 to 97 on the low end, and the high end is around like between about 160 and 200 around that. And that's pretty much our setup.